Hello, internet peoples of the internet. It's me, Mimi05, and I'm here with another computer that I have built. This one I did multiple time lapses on, I think a couple months ago, with me building it, but I haven't actually showcased it. This one is not 100% done, but I might not continue working on it. You should comment down below and let me know if I should work on it, or click the poll in the corner, because I'm probably going to put one there. So anyways, this thing has two programs. You have play falling pixels, only use 8 of 10 pixels. Oh, move pixel player. There it is. Okay, I got lucky. Move pixel player. And move. See this one, like with how slow the computer is. Oh, I ended up over there. Dang it. With how slow the Redstone computer is, you kind of have to think like before a signal actually reaches a place, see? Because, like, somehow I'm still alive down here. Not for long. There's the character, and boom, I'm dead. No more pixels will fall from the sky. I mean, these ones will continue to fall just because, like, it works by sending a signal through here, and then the signal to each pixel is just delayed by a certain amount, so it works on just one signal. And then I also have an animator over here. This is the animator. If we just push, let's see. If I just, this animator is actually fixed. Like, the one I built previously was actually kind of broken and all the buttons were weird, but this one I actually spent a little more time working on. So if we push that corresponding pixel should appear up there. There we go. They're pretty large pixels as well, because I was gonna actually do the whole thing, but you couldn't. I want these to be usable and buildable and survival, but you couldn't quite reach it if I didn't make them that big. So let's see. As it's loading up on the screen up there. There it goes! It doesn't look nearly as good as I expected it, but that does kind of look cool. And then we can save that to frame 1. This has up to 5 frames, as you can see over here. This is the storage up here. This is the memory storage right here. So that has saved to frame 1, which I believe is this right here. Yeah, it's this right here. It's been such a long time since I built this. I hardly remember half the stuff that's in here. So this is frame 1, as you can see. This is a 0 as it is off, and this would be a 1, and this is just a giant binary code that creates the image that's displayed on the screen. This would be 0 1 1 1 0 1 0 0 1 1 1 0 1 0 1 1 1 0 0 1 0 1 1 1 0. And all those ones and zeros look like this when displayed on the screen. So then we could, if we invert all these, that might look kind of cool. And then it'll load up. This is like, this computer is so huge that it actually just takes so much time for the signals to get places. So we've inverted the signal. We're gonna save. Oh, that's loading the frames. Ooh, I should I'm gonna clear this off real quick. Oh no, wait, those are empty pixels. Well, here we get to watch them disappear and then reappear. Well, then that should do it. Oh no, because I had loaded it up. Let's unload that. And then we should, once that unloads, maybe potentially, this might actually be frame 1. I'm gonna look just by fault. Yeah, that's frame 1. Okay, unload frame 1. There we go. It's unloading. That is like the coolest thing ever. Like, I built this thing and it's just so cool to watch work. Like, oh man. Okay. What happens if we play the animation? Where's the play animation button? There it is. Is there any information in there? See, unfortunately, the problem with the animation part of this is that it's just so huge that apparently that was the only frame. But I'm pretty sure that's a lie. Whatever. It's so huge that it actually has such a large delay when playing the animation that by the time it loads the top of the screen, it's already starting to unload the bottom of the screen, and it's playing the next frame before the first frame even finishes playing. So that's one of the big downsides for it being this humongous. I mean, this is the GPU right here. I mean, this GPU is massive. Like, this is what? There's it's a 10 by 10 screen, so that's 100 pixels. There's a gap in between each input here, so that's 200 blocks in that direction. And each pixel, so that's 20 blocks up and 200 blocks there. And then probably 20 blocks that way. So that is absolutely massive. 200 blocks in that direction. We can see, look at my statistics, items, times used. I've used 33,846 redstone, 13,592 cyan wool, which is what the GPU is made out of, and then 9,574 light blue wool, which is what I was using for the busing over here. And then the storage was the next big thing. That was like, yeah, 8,350, 3,784 repeaters, 3,338 yellow wool, 2,210 slime, 1,764 sticky pistons, 1,656 iron. It is absolutely massive. Look, 1,237 redstone blocks, 492 redstone torches. Okay, that's not so bad. 441 observers, 163 redstone lamps. I just punched my microphone. And down here at the very bottom we have hoppers, which is 2. We have 21 comparators. But the point, you get the point. It's absolutely massive. And it is really, really cool. So I'm going to go ahead and manually reset all the information stored in this part of the computer just by doing this. So all these frames are empty now. And if we come up over here, man, see, like, if this were real life, these redstone wires would be microscopic, and all this would be working, like, in the size of my pinky. Smaller than that. Like, they would be working in the tip of a pinhead. Because, like, while it is not exactly like real-life electronics, it is actually very, very, very similar. Like, the only difference is you don't have to worry about power, you don't have to worry about ground, and you don't have to worry about completing a circuit. Those are the three main things you don't have to worry about. That's different from real-life electronics. Also, you don't have to worry about magnetism, technically, but I'd say that quasi-connectivity within Minecraft is probably closer to the magnetism in real-life electronics that I'll count it. Okay, so now that I've actually gone and manually cleared out the information from the animator thingy up here, I'm actually going to start drawing some random things, I think, maybe. There we go. That is my attempt at a sword. It might be pretty crappy. Here, let me just... Yeah, there's not enough pixels to be doing something like that. There we go. That's a better attempt at a sword. And then I'm going to save it to frame 1. And then as we can see, this is what our sword looks like in ones and zeros. 0, 0, 1... 0, 0, 0, 1, 1, 1, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0. That's what our sword looks like in ones and zeros in this binary code that I have here. And then, let's see, I wanted to swing. So we're going to move the bottom out from the middle and we're going to move it to there. So, yep, there it goes. And then that'll stay put. This will move up. This side will move down. Let's see that does that. Yep. Okay, so now the middle part here that starts, let's see, 3. So 1, 2, 3. And we just delete these then. Those two. Might be this one as well. There we go. And then, so it's here, here, and here, and here. There's the swinging of the sword, and then we're going to save to frame 2. Again, it's saved right here. I could have, like, the computer automatically figure out what frame you're on, and then maybe have, like, want to have, like, 20 frames or something like crazy like that. And then we could have the computer automatically count which frame you're on, and then you don't have to just have one button. Beep, 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 beep. That would be really cool. Anyways, Let's see, it's kind of like this, I believe. So now we get to watch it disappear. It is so cool just watching it disappear. Alright, so now we have it here on the ground. It has swung. We're gonna have that in frame 3. We could just have it like do a full like all the way down. Like that doesn't have to be the ground, especially since the hilt is kind of clipping into it. What? Oh, I didn't erase it. I was saving it to frame 3. There we go. And then the bottom's starting to move up. There we go, frame 4. Watch it disappear. And there's our simple frame 5. Now each of the frames are saved, so we can erase that, or it'll be saved by the time the... I mean, when you click save, like the data doesn't necessarily have to get there before you start changing it. It just has to... You know, we can also test the ping time. I forgot to mention that. I was gonna have like a roll dice, generate terrain, randomize image. And I think I still will. So let's see. Test ping. There's from the button signal. And there's from the signal to get all the way from one end to the computer and back. So that's how fast the ping will ever be. That's how fast a signal will ever get from one spot to another. So now if we play animation, it's over here. There we go. First frame. Unfortunately, with this very slow ping time, by the time it's already up and loaded, it started to unload, but I think I could fix that just with some pulse extenders. So there we go, that's our 5 different frames. That's everything I've built so far. This is kind of like a numpad for whatever reason. I don't know what I was going to use that for. I hope you guys did enjoy. If you did, please do smash the like button, and I'll see you guys in the next video. And I will leave a download for this in the description once it's finished. So look forward to that. And goodbye!